Uh, Hello student, today I am going to teach you about the greedy method. There are two categories of approach in which we can solve a problem, either through the dynamic programming or through the greedy approach. I have already told you about the dynamic approach. The dynamic approach and greedy approach both are used to find the optimal solution. Means the optimal solution, but they are quite different from each other. In dynamic programming, there is a guarantee that we shall get an optimal solution. But this is called the concept of optimality, and dynamic programming approach assure you that the final solution would be the optimal one. But in case of the greedy approach, the solution may be optimal or may not be optimal. So the difference is that in dynamic programming and greedy programming, greedy method, the difference is optimal solution is guaranteed. In greedy approach, may be, may be optimal or not. This is the difference. But why would we go for a method which do not give the guarantee that the answer would be the optimal one? The reason for this is that this is very time consuming. It is very time consuming, and this one is faster method, right? This is the point that the greedy approach give you a very fast solution. That's why this approach is used many situations, because in dynamic programming we find out all the possibilities and all the possible conditions, and after that we take the step and we reuse that sub problem solution to get the final optimal solution. But this is the sequential approach in which we take a decision at a moment, and we cannot backtrack the decision even if we know that this decision is not right. So in this approach, we move in a faster way, but there is no surety that the answer would be optimal one. But in this operation, dynamic approach, we check out all the possible condition, and only after that we take a step. So this is faster. Each one has its own advantage and disadvantage, and because of the its robustness, dynamic programming is most widely used. It is much popular, but there are situations in which you go for the greedy method. So here I shall discuss the greedy method to give you an detail about it. The one of the most common problem with the greedy approach, so that you can understand the idea, is the activity selection problem. Activity selection problem, I shall solve this problem in the next class with help of dynamic also, but now I am focusing on the greedy method, and here I am going to give you two examples of the greedy approach. One is the greedy approach of activity selection, and another one is the greedy approach for a knapsack problem, fractional knapsack problem. So first I shall start with activity selection problem. First of all, what is greedy method activity selection problem? Suppose there are number of activities, and you have to, and uh, some of these activities are which are not in which are in conflict with each other, and among the set of these activity, you have to find out the combination with which we get the maximum number of job done. To get an idea, suppose you want to run a multiple programs and there are multiple lectures in the college, and you want each lecture has its start time and its end time. No two lectures should collide with each other or overlap with each other, and you want to run maximum number of lecture, and the time duration you cannot shift that the starting time or end time of the lecture, but besides that you want to run some extra courses. In that case, and there are various options. So in that situation you will try to find out what is the optimal selection of the problem, so that we can run maximum number of lectures during a day. So to better understand idea, I shall give you an example with which I shall explain you. This is a very simple one. You will understand it by just taking a look of it. So the question is, there are certain set of problems I am designing. Activity 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Start time, and finish time. The start time is like that: 1, 2, 4, 1, 5, 8, 9, 11, 13. 5, 7, 8, 9, 10, 11, 14, 16. Okay. Uh, So here is a chart. This chart shows that there are 9 activities. This is the activity 1, 2, 3 up to 9 activities, and the activity 1 start time is 1, and activities 1 finish time is 3. Similarly, activity 2 start at time 2 and end at time 5. Activity 3 start at time 4 and end at time 7. Like this, here we have to select the optimal set, or the set with the maximum number of the activity, using the greedy approach. As I've told you, in greedy approach, it does not wait, it does not check out all the possibilities that could arise in future, and it does not guarantee that you will get the final solution. It can give you multiple solutions also. Here, when you will find to select an activity, then you give uh, after selecting an activity, you cannot terminate in between. You can select another activity only after the finish time of the first activity, and after the finish time, the activity which starts after it, that only can start. You cannot start an activity. Suppose here, if I choose activity 1 to run, then it will start at time. Suppose I am taking the diagram. Suppose I am activity, and these are the time slot 1, 2, and 3, and activity start 3, 4, and 5. Here the activity start at time 1 and activity 1, right, and ends at time 3, and activity 2 starts at time 2 and activity 2 start at time 2 and end at time 5. Here, since it is a greedy approach, it will not wait for 1 extra minute. It will just start with the activity 1, and after the starting, it cannot select another activity. Somebody may think that if it is greedy, then it will find out that this activity uh, it cannot choose any other activity in between this. So once it get over, then only it can select it that another activity. But meanwhile the activity to start time has gone, so this cannot be chosen because there is an overlap between these two activities. So you cannot select two activities which are overlapping with each other. So you cannot opt for activity 2 when you have opted for activity 1. So here in this diagram, if you have selected, suppose I have selected activity 1, means A1, I am representing it by A1. If I have selected activity 1, then I cannot select activity 2 because its start time is equals to 2. But I can choose activity 3 because among all these activities, the next activity that is in waiting, or that is next upcoming activity is activity 3 that start at time 4. All the other activities, this activity cannot be selected because its start time is 2, that is already gone, and this activity cannot be selected because its start time is has gone. So somebody may choose this activity also. In this activity, sorry, in this activity 1 to 3, you may opt for 1.3 or 1 to 8. But if you have to select the maximum number of activity, but here this activity is of time spent 2 and this activity is of time spent 7. If two activities are coming at the same time, to run maximum number of activity, you will go for the activity which has shorter time span. So I shall opt activity 1 instead of activity 4 because this is taking more time than the activity 1. So I have not opted for activity 4. So I have selected activity 1, and since I have selected activity 1, activity 2 cannot be selected because its time is in between the 1 to 3. And similarly, this has already been discarded. The next activity which comes first is with start time 4, so it would also be selected A3. Okay, after selecting A3, its time of span is equal from 4 to 7. So the activity 5 is lies in between. This runs starts in between. So this activity will be aborted. This will not be. This will be aborted, and this will not be chosen. So we shall cancel that activity. The next activity after time 7 is activity 6. It will start at time 8 and after, that is after this activity A3. So we shall opt for activity A6, right? And after selecting A6, the activity 7 which starts in between will be aborted because its start time is in between 8 and 10. So this cannot be chosen along with activity 6. The next activity which comes first is A8 because it start after 10. So next activity will be chosen as A8. Okay, and next activity A9 will be discarded because this activity starts that and between the running time of the activity 8. So this will also be discarded. So the optimal set would be A1, A3, A6, A8, right? So the optimal set activities optimal set here. One point you should remember that in greedy approach gives you only single solution, but in dynamic approach, if there are more than one possible results, then it will give you all possible results. So in dynamic programming, for example, here we can also there could be another set with help of which we can choose another 4 activity. For example, 2 to 5, if we opt for Q2, A2, A2, then this ends at 5, and after that A5 because it start after this 5, and then 5, then A7, then A8. Okay, A8. So this could be another optimal solution, but here greedy solution will give you only one solution, but in case of dynamic approach, it will give you all possible solutions with the maximum numbers of set. So greedy approach give you one solution, and it may be optimal or it may not be optimal. It does not give you guarantee that it would be the optimal one. Okay, but why we go for such a solution which do not give you optimal results? Because it is much faster than that. There are certain situations in which we go for greedy approach. This activity selection problem is solved using the dynamic approach also, in which we'll get all the possible solutions. So that is more time consuming but give you a guarantee, and so dynamic approach is much more popular than the greedy approach. The another method problem that we solve with help of greedy approach is the fractional knapsack problem. Right? The fraction. What is fractional knapsack problem? Actually, the fractional knapsack problem is a very simple problem that even a primary student can solve. But this is in one of the basic math numericals that give you an idea of the greedy method. What is in fractional knapsack problem? You are allowed to pick a fraction of the item. Okay, and you can take a fraction of item, and suppose there is a knapsack, means there is a sack in which you have to put certain item so that you get the maximum profit or maximum value of that item. Suppose a thief enter into a house and there are 10 gram of gold, 10 gram, 20 gram of silver and 30 gram of uh, brass, suppose. Then what he does, actually he find out that he knows that the gold is the maximum valuable one among these items is the maximum most valuable item. So he first what he does, he picked that item gold. The first item chosen by the thief is gold, and after that he selects silver, and after selecting silver he opts for brass. But if he is just having a small bag with a capacity of 20 grams, then first he will fill it with the gold, then with the silver. This is the situation that we deal. This is the scene with which help of which I wanted to give you the basic concept of this numerical. Here there are certain items and their weight and with their weight and their values. Here we find out which among these items is having the maximum value, and with and we want to fill a given knapsack with certain weight, fill with most valuable item first, then after that we fill the best sack with the second most valuable item, then with the third, and the so on. So I shall explain you this with an example. Here the question is, suppose I am taking the item weight and cost. Okay. Suppose I am taking item as A, B and C, right? And the weight are 10 gram, 20 gram and 30 gram, right? And their cost is 60 rupees, 100 rupees and 120 rupees, right? So, and the sack that we have to fill is of capacity 50. The knapsack capacity size, simple word size, is equals to 50 gram. Okay, you have to fill a sack of size which can be filled with, which can which capacity is 50 gram, and we have to fill the item in such a way that we get the maximum valuable item in the bag. Knapsack, you may simply name it as a bag. There is a bag which can hold maximum 50 gram of weight, and these are the items with their weight and their cost, and you have to fill this bag which can hold 50 gram of weights with the items, so that the maximum, the bag has the maximum value. So what you will do here, you shall find out. One second. So I am writing it on this side. Bag capacity or knapsack, bag or knapsack, of whatever you want to say. Sack size is equals to 50 gram. So we want to fill the bag with the most valuable item first. As in case of thief, he wanted first what he picked in his bag, gold. So here we shall find out the most valuable item. So for finding out the most valuable item, that item will be most valuable, for which per unit cost will be the maximum. So per unit cost would be 60 by 10 is equals to 60 by 10 is equals to 6. Here 100 by 20 is equals to 5, and in this case 120 by 30 equals to 4 rupees per gram, 6 rupees per gram, 5 rupees per gram and 4 rupees per gram. So the most valuable one is the item A. So we shall pick first item as a whole. Suppose this is the bag. This is the bag. We shall fill the 10 gram of item A. 10 gram of item A. Okay, because this is the most valuable item. Its per unit cost is equal to 6 rupees per gram. And next item, next valuable item is item B. This is 20 grams. So we shall fill this 20 gram of item B, right? And after that, the bag yet can hold 20 gram extra, and this item is of 30 grams. So we shall pick only a fraction of it, that is of 20 grams of this 20 gram of item C. So 20 gram of item C, right? And this would be the capacity 50 gram. 50 gram, right? So what will be the optimal solution or the value of the bag in this case? For 10 gram, value will be equals to 60 rupees. This 20 gram value would be 100 rupees, and this 20 gram 30 grams cost is equals to 120 rupees. Then 20 gram cost would be, this is a simple numerical, there would be 4 into 20, means 4 into 20 means 4 cross 20 means 80 rupees. So the optimal solution, so the optimal weight value of bag or knapsack is equals to is equals to 60 plus 100 plus 80 is equals to 240 rupees. So this would be the solution, right? So this would be 240 rupees. So this is the solution. So the greedy approach are very easier method, but they do not assure you that the answer would be the optimal one. It may be optimal. So these two questions are very simple and I have shown you. So I think that this was quite understandable to you. Thank you.